Hello, my friends. Today we are going to cover a very important topic that is Amazon Redshift. As the massively parallel processing data warehouses are taking larger space in the customer architectures, so we can see Redshift have significant presence in many for many customers, right? So today I'll be just talking briefly about the Redshift architecture. It's a very high level architecture overview. I'm just creating small Redshift or AWS component videos because what I observe that whenever a person go for an interview, because I'm working as a panel and what I understand that a lot of time it is very difficult to remember all the concepts for all the tools or technologies which you have worked on. So these videos will definitely help if someone is just going for the interview, they can brush up their knowledge memory, and also if somebody is starting as a new on these components, they can refer to these small short videos which will give them the concepts. Now if you can see the picture in front of you, that is the Amazon standard Redshift architecture picture. So I'll be just discussing today for provision Redshift architecture, not the serverless, because Redshift is available in Amazon two ways. Either it is serverless or provision. So if you see provision architecture, if you can see on the top of the screen, these are the clients, JDBC, ODBC, or data API, BI reports, which basically will redirect the call to Redshift. Right? Redshift is a data warehouse which is placed in the cloud, and that is the Amazon answer to the data warehouse. And then what happens whenever the request will come, these basically come to the leader node, and leader node eventually take the request from the user, and it will create multiple tasks and it will distribute those tasks into compute nodes. We'll be discussing in detail. Now, if I go to the next picture, if you can see what is leader node, right? So what does leader node does? So leader node, as I described in the previous picture, right? Leader node accepts the external client application request. If you can go back to the screen, you can see this can be a JDBC, ODBC application, BI reports, or data API, which needs data. So it basically give the request and will reach to leader node. So leader node will take the client application request and handle the SQL query execution. For doing that, leader node parses SQL query and generate the query execution plan. So query execution plan means what will be the step to execute the query. Suppose you are writing a select query where you are doing some aggregation, maybe sum or maybe average, and you're doing some group by, right? So query execution and there will be some joins also. So query execution plan is basically step-by-step approach. What will happen when the query will execute? First, it will do join, then it will load the data, then it will basically try to apply the aggregate, right? It will apply the Windows functions, and then once it is done, then it will basically create this multiple task and then distribute this task into each compute node. So suppose I'm doing some calculations, and then maybe I'm aggregating some values department wise. I'm just trying to understand what is the average salary, right? So for each department data, it will put in a single compute node, and it will calculate in parallel in the compute node. So leader node will basically create multiple tasks and distribute those tasks to compute node. And leader node obviously does not store any user data because it is mostly for execution of the query or managing the query execution. Leader node aggregates all the results coming from the multiple compute nodes, and finally it sends the final result to user. So what is going to happen if I just go to picture? You can see when the compute nodes are running in parallel, once they finish all their computations, they will one by one go back to leader node and they will give back the result. And then the leader node will basically aggregate these results and it will again send back to the user. Hope the leader node concept is clear. Now I'll move to the compute node. So compute node is obviously it is what it is doing. It is actually executing the query processing logic. It obviously stores user data because it is computing that data. And once the task is completed, as I earlier said in the earlier slide, that when it completes, it will basically give control back to leader node. Okay, this is a repetition. And compute node basically store the user data. Now, this concept is very important, slice. So, whenever Redshift actually process the data in compute node, right, it will divide this data in different slices. So, each compute node is having multiple slices. And if you can see, I'm just draw picture A to G. These are the slices, and each slice actually gets the portion of the nodes, compute nodes, memory, disk space, processing power. Right? It will be distributed. And what will happen, the data is distributed among the slices for parallel execution, because if it's a larger set of data, maybe if you think that it's a 6 million rows, right, so each slice will get a million copy of the data, and it will process in parallel. Now, I think you are now clear on the architecture side. Now, when we are talking about the architecture, so basically Redshift have two types of node types. Whenever you are actually using Redshift, the compute nodes, that can be of two types. One can be RA3 nodes and one can be DC2 nodes. So RA3 is kind of a, if you could see this picture, so RA3 node is kind of a like SSD storage kind of an arrangement where the queries can run on the cache, and they also have a managed storage. So basically, what happens whenever you are running a query, if the data is small amount, then it can be processed using the local storage using SSD and cache. But if it is a high volume data, then RA3 will manage itself by pushing the data into S3 and doing the processing. Now these are the RA3 types which is available. It can be single node or multi node. You can have RA3 large and then RA3 X plus, right? RA3 4X or 16X large. Depending upon the size, the cost will increase, also the capacity will increase. So DC2 is a dense compute. If you have a very compute intensive queries, then I will prefer the DC2. And DC2 don't have any managed storage. If you don't have a DC2, it is a local storage only, but it is a very fast processing of the queries. Now, when we should use DC2 and when we should use RA3 for dataset under 1 terabyte, where the computation is a priority, then we will prefer the DC2. But if we expect the data to grow and huge data is growing, then we will prefer the RA3 node. Hope you enjoyed the video. Please do watch and subscribe.